Hello engineers, welcome to Chris Control Automation. This time we're going to continue the PLC hardware configuration that we are doing. Okay, yeah, in the first video we ended here. Okay, yeah, we ended here, so we are going to continue from the signal models, okay, or the schematic model. In the morning, let me see. Yeah, in the first video I wrote schematic model, right? Okay, let me do it. Signal models, okay, signal model, the SM, all right, the SM, yeah, signal model, all right. So I prefer the signal model, okay, the SM, this one, all right. That those are the digital input and output models, right? Yeah, yeah, signal models, the analog input and output. Yeah, I think this one's, let me show it to you. Yeah, these models, okay, this one's, okay, yeah, all right. It should have been signal models, okay, signal models. That is the correct name. Yeah, so let's continue from there. So in the morning we ended here in the first video, okay, we ended here. So now we are going to continue from the signal models, okay. Now, yeah, I'm going to start from this model, right? I hope you are seeing some numbers here, okay. We have DI8, okay, by DC 24 volt, all right, and then AI5 slash AO2 by 12 bits, okay. So let me explain this things for you here now, right? So now we are on the signal models, okay. Yeah, signal models, right? Signal models, okay. So now signal models, so we have let me come back. Let me go to this side small. Yeah, so we have DI8, all right, by DC 24 volts, all right. What this thing means is that, okay, this model, are you using this model, all right? This model, okay, consists of 8 bits, okay, digital input, all right. The DI means digital input. The DI, it means digital input, all right. The DI over here, it means digital input, okay. So this model, okay, consists of a digital input and what, an analog input and output. This one is analog input, the AI, and then the AO is the analog output, okay. So it means that it has 5 analog input channel, right, and then 2, okay, analog output channels, all right. And then the DI means what, 8 digital input, all right. Yeah, 8 digital input by DC 24 volt. It means that if you want to connect a push button to it, okay, the push button should have a voltage of DC 24 volt, all right, 24 volt DC, all right. Yeah, it should either a signal, like, a sensor, limit switch, okay, like inductive proximity sensors, capacitive proximity sensors, photoelectric switches, or push buttons, okay. Yeah, they should have DC 24 volt, okay. So it means that it accepts DC 24 volt, this DI8 by DC 24 volt, all right. Yeah, it's a signal model, all right. So PLC always accepts DC 24 volt for the at the digital input side, okay, at the digital input side. So this numbers here is telling us that, okay, this model, okay, is receiving 8 digital input bits, all right, 8, which is DC 24 volt, all right. Now, so over here, all right, you see some numbers here. These numbers, okay, they are called channel numbers, okay, channel numbers, or channel numbers, okay, or or bit, okay, bit address, okay, but I'll prefer the bit address. Okay, I'll tell you why I'll prefer the bit address. Now this one, okay, this numbers here, this the whole all of them, they are all 8. When we are counting, we will start from 0. Okay, so 0 will be our first number. So 1 2 3 4 5 6 7 8. It means that this model, okay, it consists of 8 bits address, 8 bit address, okay, 8 bit address. So it means that now if it is 8 bits, all right, you know that in digital electronics, if you can go back in digital electronics, 8 bits means 1 byte. 8 bit means 1 byte. Okay, so it means that this whole numbers, okay, they are all together called a byte. Together they are called a byte. These numbers, okay, they are all called bytes. Okay, byte address. So now we have it, we call it byte 0. These whole numbers, okay, they are all byte 0. Okay, byte 0. So now we have byte 0, okay, byte 0, okay, which consists of what? Consists of bits address. Okay, it's got to bit address 0 bit address, okay, which consists of 8 bits. Sorry, it's called 8 bits. Okay, by 0 is equal to 8 bits. All right, 8 bits. Okay, 8 bits address. All right, 8 bit address. I'm using it. So this one is byte 0. The whole of these numbers, they are together called by 0. So it means that this this side, this channel, okay, this input bit, all right, they are all called byte 0. So now byte 0 consists of 8 bits, 8 bit address, which starts from 0 1 2 3 4 5 6 7. So these are the bits address of this byte 0. Okay, this alone, okay, this alone is bit 8 bits is equal to 1 byte. Okay, so now when you are in digital electronics, okay, when you are counting, we start from 0. So it means that this one, okay, these numbers, they are all together called bytes. Okay, byte address, byte 0. Okay, so that byte 0 consists of 8 bits. Okay, all right. So now we will come there. Okay, when we are doing the software configuration, you will understand it much better. All right, so let's go to the AI5. Okay, AI5. All right, the AI5/E02, okay, by 12, okay, bits. All right, by 12 bits. Now what this AI, all right, what this AI 5 mean is that, okay, this same model, all right, this model, okay, I told you earlier that it consists of both digital input, okay, channel, at the same time analog input and analog output channel. All right, yeah. So what it means is that it has the AI5, okay, it's called to what? 5, all right, 5 analog, okay, input channel, all right, okay, which is equal to channel 0, okay, channel 1, channel 2, channel 3, and then channel 4. All right, yeah. So when you count them, it will be 5. 1 2 3 4 5. Okay, in digital electronics, if you are to count numbers, we start from 0. Okay, yeah, that is binary. Yeah, something like that. Yeah. So we have channel 0, channel 1, channel 2, channel 3, and then channel 1, okay, channel 1, channel 2, channel 3, channel 4, and then channel 5. All right, but it will start from 0 to 4. Okay, so that is what this AI5 means. Okay, Yeah, it means it has 5 analog input channel. All right, yeah, 5 analog input channels. Okay, yeah. So when you're counting, it starts from 0 1 0 1 2 3 4. Okay, but they are all 5. All right, yeah. And then the AO2. All right, the AO2. Okay, yeah, it's equal to, it means that it has 2 analog, all right, output channel. Okay, 2 analog output channel. Okay, which start from 0, okay, to 1. All right, 0 to 1. So when you will count, there will be 2, 1 and 2. Okay, 1 2, but start from 0, channel 0, and then channel 1. Okay, so this module alone consists of a digital input channel and analog input and analog output channels. All right, let me show you some pictures here. Okay, let me show you some pictures here. All right, now you see here, these are the terminal numbers. Okay, the terminals. All right, yeah, these are the terminals. All right, let me show you something here. You see that we have these gates. All right, we have these gates. Isn't it? We have these numbers. We have vein. If you can see it, we have vein. Okay, vein, and then A. So 2 is vein, 3 is A, 4 is the common. 4 is common to all of them. Right, so they've written AI0. I hope you can see it well. AI0, which means that this is channel 0, this is channel 0, right? This is channel 0. So channel 0, you have voltage and then current, voltage and current. So in case you want to measure an analog signal that brings out a voltage signal, okay, that brings out a voltage, it means that you are going to use the 2. Okay, and then if that sensor, let's say a temperature sensor or potentiometer or pressure transmitters, okay, let's say it's 0 to 10 volt DC, 0 to 10 volt DC, you use this side. Okay, if it is 4 to 20 milliamps, okay, it means it is current, so you are going to use this side. Okay, yeah, and then the 4 is common to all of them. 4 is the common, the negative side. 4 is the negative side. Okay, 4 will be connected to a negative volt DC voltage. Okay, now they've written here A0, which means that the whole of this is channel 0, channel 1. Okay, channel 1, but channel 1 is start from 0, AI0. Okay, so this side, you see this side, all right, you see this side, the whole of this side. Okay, this side represents this side, okay, it represents this side. Are you seeing it? It represents this side. Are you seeing this side? So the whole of this side, this is the gates. All right, so the left side here, okay, the left side here, all right, here, coming down here, it represents here. All right, so the top here is this, and then the down here is also this side. Okay, when you come to this side, see this side. Okay, let's finish with the analog side first. Okay, yeah, small. Now let's see here. As I was saying this side. Okay, the left side here, there are two. You have here and then this side. Okay, so this side is this, and then the down here, this side, okay, is also this, the down here. Right, now so let's count the channel numbers. We have channel 0. Okay, channel 0. All right, and then we have channel 1. Okay, AI0, this is channel 1. The whole of this channel 1. If you are counting, okay, if we are counting, see here, we have 1 2, you see this one, okay, this one, All right, we have 1 2 3 4 5, but when you are counting, start from 0. Okay, so now channel 1, this is channel 1. Okay, so it should be AI0. Okay, channel 1 will be AI0, so it should be AI0. Okay, and then AI1, and then AI2, and then AI3, and then AI4. So these are the analog input channels. Okay, so when you count, it will be 5. 1 2 3 4 5. All right, but start from 0. Okay, so now they've written you see here, they've written AI0, so that is the channel 1. Okay, and then you come down here to AI1. all right, AI1, that is this. Okay, so that one consists of 5, terminal 5, terminal 6, and then terminal 7. all right, and then we have channel 3, that is AI2. okay, this is it. 1 2 3, so channel 3 is AI2. Let's go downwards. Okay, now we have channel 4. When you are counting 1 2 3 4, channel 4 is AI3. okay, so now this is it, AI3. okay, now then channel 5, when you are counting 1 2 3 4 5, so this is 5 is AI4. Okay, so now we are done. Let's come to channel, the analog output, so we have EU0, okay, comma, and then EU1. all right, so this is it. This is the analog output channel. all right, this is the analog output channel. Okay, so channel 1, channel 2. So let's see here, we have EU0, so this is the analog output. okay, EU0, and then we have EU1, analog output 1. so that is that. okay, and then the 20 is the negative of for the whole output block, because the 20 is common to all of them, so that's the negative side. okay, and then these ones will come from we'll go to the sensor. This analog output, that's where you control the speed of variable frequency drive, and then you open a valve. okay, yeah, so this one is going to a device, but the analog input, okay, it is an input signal coming from temperature sensor or pressure transmitters. okay, so they will be connected to this side, because we are receiving an analog signal from those sensors, so they are for the analog input channels. okay, but if you want to control a particular valve or frequency drive, because we are going to give that particular device a signal, an analog signal, so to go from the output channel. okay, so now we are done with this. Let's look at the digital. okay, the digital, I said we have a byte 0 consists of 8 bits, right? 8 bits. In that 8 bit, we have bits 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7. But when you count them, they will all be 8. They will amount to 8. 1 2 3 4 5 6 7 8. Alright, so let's look at this side. You see here, these are the input. Okay, the analog input bits. The digital input bits. Okay, the digital input bit. So let's count them. We have 1, okay, 2 3 4 5 6 7 8. The terminal 30 is a negative. All right, yeah, so means that from terminal 22, 23, 24, 25, 26, 27, 28, 29, they are the input, the digital input channels, okay, or terminals. All right, yeah, so this is bit 0, okay, bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, as we have here. All right, 0 to 7, so they are this. Okay, so we are done with this model. All right, yeah, but let me show you something here. in case we want to program this model, okay, this the digital input, what we do is we do it. There's something we call, let me bring it down here. There's something we call that we have input, okay, we have input input address, okay, we have input address, okay, input address, which is I, all right, which is I, and then we have memory, okay, memory, okay, let me say output address, output, okay, output, okay. Now we are dealing with input, so let me forget about the output. So we have memory, okay, address. Yeah, when we are doing the programming, we'll be doing all these things, but I want you to understand from here first, so that when we start, you will not get confused, okay? Yeah, so this memory, we have memory address, but for the input address, all right, input address is, the input address means that you are connecting as an external input, okay, to the PLC, an external input to the PLC, okay. The memory address means you are using an address from the PLC model, from this PLC CPU model, okay. Yeah, so let me show you something here. Now, if in case you want to connect a push button or a sensor, okay, a push button is outside, they are all peripherals, okay. So it means that you are going to connect the push button to the PLC, all right. So now it means that the push button is an input, device. So we are going to assign I to it, okay. So that I is the input input address, okay. Now after the I, we have something called byte address. I told you that the whole of this 7, this bits, okay, they are together called byte. So it means that this whole block is called byte address. So it is byte 0 I talked about earlier, okay. I talked about it earlier. Byte 0, it consists of 8 bits address, and this is 0 to 7, right? Like this, these are the numbers 0 to 7. So it is called byte 0, consisting of 8 bits. Now, in case you want to connect a push button, okay, a push button to this model, all right, to this input address, all right. What we'll do is, okay, we are going to connect it at byte 0, okay, byte 0. So it means that this byte is what is 0, right? This byte is 0. So now it should be input byte 0, okay, input byte 0 dot which bit address are you going to connect the push button or the sensor? Which input bit, okay, are you going to connect it at 0, okay, at 0 or 1 or 2 or 3? Which side? So let's assume that we want to connect it to, let's say, which side? Any bit number at all. So let's say 3. Okay, you can choose 3 or 2. So let's choose 3. So it means that we are coming to connect the push button at bits 3. So in case you want to tell the PLC, okay, that you have connected, okay, a push button at bit 3, okay, at bit 3. So this is how I want to do it. It means that it should be input address I, okay, input address I, and then byte. Which byte? Byte address 0 dot 3. The 3 means the bit address. So the moment you input this thing, okay, the PLC will know that you are referring to this bits, okay. Yeah, the reason being that we have this. I'll come to this side, okay. These are all byte addresses, but these are all byte addresses, okay. But this is byte 1, okay. This is byte 1, byte 1. This is byte 0, byte 1, okay, and then byte 2. This is by 0, byte 1, then by 2, because this one is different model, different signal model. This one is also another signal model. Okay, I'll come there. Okay, so now the moment you tell the PLC that I0.3, it means that the PLC will know that no, you are referring to byte 0, and then bit 3. The PLC will know that. Okay, the PLC will know that. So now, let me clear it. Okay, in case you want to tag, or you want to do the addressing, in case you want to do the addressing, to start from I0.0, comma, okay, and then I0.1, comma, okay, and then I0.2, comma, I0.3, comma, I0.4, comma, I0.5, comma, I0.6, comma, I0.7. We are done. So in case you want to connect push button to this ones, okay, so the first one, I0.0, it is this bit. It means that input byte, okay, input byte, okay, 0, input by 0, bit 0. So this one, the first one, okay, it is input byte, okay, input byte 0, okay, this is by 0, and then bit 0. Okay, now we have I0.1, it is input byte 0, okay, bit 1, input by 0. This one is by 0, the whole of this block is byte 0. So I0.1 means input byte 0, okay, bit 1, okay, and then I0.2 is equal to, it means that input by 0, okay, bit 2, in that order up to I0.7. I0.7 means input byte 0, bit 7. So in case you connect push buttons, sensors, whatever, okay, to this input input channel, okay, the moment you enter I0.7, the PLC automatically will know that you are referring to byte 0, bit 7, and then it is an external input device, because that I means is an external input device. At the moment I write M, okay, M, let's say M0.0, okay, here is I0.0, but when I come to memory address, the PLC will know that, okay, you want to use the internal memory address, though that one the PLC is not going to use, it's not going to use this byte address. Okay, you can equally use M0.0 in the program. At the same time, you can use I0.0 at the same time. But when you use I0.0, the PLC will know that you are using the bytes, okay, byte 0 address 0, the byte 0 bit 0. But when you at the same time use M0.0 in the same program, the PLC will not refer you to this place. It will know that you want to use the memory address in another program, in the same program, in another, let's say, location in the same program. But because it is a memory address, the PLC will not come to this side. But the moment you do it, you enter I, the PLC will know that you are referring to external device, input device. So it will come to this side. Okay, so equally you can use M0.0 and I0.0 at the same time in the same program. When we are doing the programming, I'll show you all these things. Okay, it is a gradual process. Okay, yeah. So we are done with this side. Okay, we are done with this side. All right. So in our next video, we are going to look at this block. Okay, this block consists of analog input and digital input and digital output. So for today we have learned about digital input and then analog input and output. All right, so now you know your data input. The data input, the same thing is going to be here. This side, the whole of this block. Okay, this one is byte 1, byte 2, because we have only 3 bytes input, 3 input bytes. This is byte 1. Okay, byte 1, yes, byte 1, byte 2, byte 3. But when you are counting, when you are programming them, it is byte 0, byte 1, and then byte 2. So these are our input bytes. Okay, input bytes, and then these are output bytes. So today you have a fair idea of input bytes. So in the next video, you are going to continue from this block. I'm going to explain this block to you. Okay, yeah, with the same numbers as I showed here. That one, it is there. I'll show it to you later. Okay, so we learn the input byte of this and then the output byte. All right, so I'll see you my next tutorial. But if you want to stay tuned, if you want to follow these PLC tutorials and understand PLC programming well, then kindly subscribe to this channel, hit the bell icon, okay, and then share this video to your friends. Like the video, put down your comment. All right, whatever you don't understand, let me see it in the comment section. Okay, yeah, this PLC programming is very intensive. It's going to be very practical, very practical. After showing you all these hardware configurations, the picture, we are going to do live video, like full video. The PLC, all these machines, all this module you are seeing, they are all there. So as I am putting the cable there, as I am fixing the cable, whatever I'm doing, you'll be seeing all these things. Okay, you'll be seeing all these things. Then the programming, the software, how to program PLC. All right, we are going to do so many things. Okay, so let's stay focused. Let's make sure that you watch all the videos of PLC that I will be uploading. Okay, so I'll see you in my next tutorials. Thank you.